Hi guys, I'm going to talk to you today about arterial blood gases, and I know it's very difficult of a topic because there are so many ways of looking at ABGs. However, I'm going to teach you a systematic way to look at ABGs, and if you do that every time, you'll get the majority of your arterial blood gases right. Alright, so here we go, we're going to start. So the trick about arterial blood gases, like I said, is to go through these 4 steps every time. Step number 1, you have to ask yourself, does the patient have acidosis or alkalosis? And the way to determine that, you have to look at the pH. So once you looked at the pH and determined whether the patient has acidosis or alkalosis, your next step is going to always be ask yourself the question, is that metabolic or respiratory? And we're going to go over how to determine that. After you answer the first 2 questions, the third question is, does the patient systems compensate for each other? Is the patient trying to compensate for the acid-base disorder? And then after that, you can come up with a nice final diagnosis that the patient has. All right, so let's start by looking at what do we expect our bodies to do. So if you look at a patient with metabolic acidosis, I like this arrow system because it makes it easier for us to look at ABGs. So if your pH is low, and bicarbonate is low, and carbon dioxide is low, we're dealing with metabolic acidosis. Respiratory acidosis, your pH is low, your bicarbonate is up, and your carbon dioxide is up. So let's go back to this one. Your pH is low, your bicarbonate is low. This means that your body is eating up its bicarbonate reserve. This means that there is an acid floating around, so it's a metabolic acidosis. Over here, your pH is low, but your bicarbonate is up. But your carbon dioxide is up, and carbon dioxide or CO2 is an acid. So if it's up, you have a respiratory acidosis. So moving on to the metabolic alkalosis, your pH is obviously up because you have alkalosis. And then your bicarbonate is up because it's metabolic, and when you have a lot of bicarbonate in your body, you will be alkalotic. And your carbon dioxide is up because it's an acid and it's trying to compensate for the metabolic alkalosis. For respiratory alkalosis, your pH is up because it's alkalosis. Your bicarbonate is down, and that tells you that it's not metabolic because the bicarbonate is down. But your carbon dioxide is low because your body blew out all the acid, which is the carbon dioxide. So Jen actually taught me something that in nursing school, which is actually a brilliant thing, if your arrows point in the same directions, you're dealing with a metabolic problem. Okay, let me repeat that. If your arrows all are down, you're dealing with metabolic acidosis because the pH is low. And if your arrows are all up, you're dealing with metabolic alkalosis because the pH is up. All right, now the opposite applies too. If your arrows are not going all in synchrony in the same direction, this means that you're dealing with a respiratory problem. So if you're dealing with a respiratory problem because the arrows are going in the opposite direction and your pH is low, you have acidosis and respiratory acidosis, as a matter of fact. And if your arrows don't point in the same direction, you have a respiratory alkalosis if your pH is up. Because if the pH is up, this means that you have alkalosis. So it makes it now very easy even for me to predict what the patient has. If the arrows are going in the right direction, I know I'm dealing with a metabolic problem. And if the pH is low, then it's a metabolic acidosis. If the pH is up, then it's a metabolic alkalosis. If the arrows are fighting with each other, or going opposite directions, then I know I'm dealing with a respiratory problem. And if the pH is low, that's a respiratory acidosis. If the pH is up, it's respiratory alkalosis. All right, so hopefully we clarified that. Now to the issue, whether we have compensation or no compensation. So that's going to really depend on your pH to a great extent. So if your pH is not normal, and give or take 2 points, then we're dealing with no compensation. And we know the range, the normal range is between 7.35 and 7.45. So give or take 2 points on each side, If your pH is not within that range, then very unlikely that you have compensation, or you might have partial compensation but not full compensation. So if you have full compensation, then your pH has to be within that normal range. So, and we'll explain that in this, using these examples. So let's start with the bottom one first. So this is a patient that has a pH of 7.32, a PCO2 of 48, and a bicarbonate of 25. So let's put the arrows around, like we said. So the pH is 7.32, so it's low. The PCO2 is 48, that's higher than 40, so it's up. So I know right away that the arrows are not going in the right direction, so I'm dealing with a respiratory problem. And the question, what is it? Because the pH is low, so I'm dealing with respiratory acidosis. Okay? So first step, does the patient have acidosis or alkalosis? I know they have acidosis. Second step, is it metabolic or respiratory? The arrows are fighting, so it's a respiratory acidosis. Okay? The third step, is it compensating or not compensating? And here I'd like to draw your attention to this little diagram here. If your pH is between 7.35 and 7.45, you have full compensation. But that's not the case here. That this patient's pH is 7.32, so it's over here. Okay? So the question that I have right now, is it partial compensation or no compensation? And that's going to depend on the system that usually tries to compensate for what we have. So if my carbon dioxide is up in a respiratory acidosis, my bicarbonate should go up because I'm trying to compensate for acidosis, so I need more bicarbonate. But because the bicarbonate is only 25 and the normal is 24, this patient has respiratory acidosis without compensation. The pH is outside the normal range, okay? And the bicarbonate did not attempt to compensate by going up to 27, 28, 29. So this is a patient with respiratory acidosis plus no compensation. Okay? Let's go up to the second example. This patient has a pH of 7.5. So does this patient have acidosis or alkalosis? It's alkalosis because the pH is up. Let's look at the bicarbonate, the CO2. The CO2 is up, so good. So far, the arrows are going in the right and the same direction. So let's look at the next arrow here, the bicarbonate. The normal is 24, we're up to 30. So look at that. We have all arrows pointing upwards, so I know I have a metabolic problem. And that metabolic problem is a metabolic alkalosis because the patient is alkalotic, right? So it's a metabolic alkalosis. So we determined that the patient has alkalosis. We determined it's metabolic, that's the second step. The third step, is it compensated or not? So let's look. The pH is 7.5, way above this, so the patient sits over here. So I'm either dealing with partial or no compensation. And we decided that it's only partial if the system that's trying to compensate for your messed up system is moving or trying or moving in the right direction. So if I have metabolic alkalosis, I expect my body to try to compensate for that by adding more respiratory acids, the carbon dioxide. So I expect the carbon dioxide to go up. Did it do that? Yes. So the carbon dioxide went up to 49, up from 40. But is the pH normal or not? No. So it's a partial compensation here, because it didn't bring the pH all the way down to that range, okay? So it's metabolic alkalosis plus partial compensation. Now, last one is the trickiest. That's why we started from the bottom. The last one, we have a pH that's 7.34. So the question, does this patient have acidosis or alkalosis? It's tricky because 7.37 falls within the normal range. So how can we say that the patient is acidotic or alkalotic? It's the standard that 7.4 is the cutoff for that. So if you're below 7.4, you're a little on the acidotic side. If you're above 7.4, then you're more leaning towards alkalosis. So for our purposes, this 7.37 seems to be more in the acidosis range. So this is acidosis, or this is trending to being acidotic, so the arrow is down. Let's see what happens with carbon dioxide. Carbon dioxide, instead of 40, it's 33. So the arrow is also down. What about the bicarbonate? Instead of 24, it's down to 17. So 3 arrows that are moving into the same direction. So I have a metabolic acidosis because I have a slightly acidic environment. So I have a metabolic acidosis. Okay? And now the question, after I determine the patient is on the acidosis side, and it seems like it's metabolic because all the arrows are heading in the same direction, do I have compensation or not here? And the answer to that, because the pH is normal, it falls over here, then I have full compensation with this patient. Compensation. So hopefully that makes sense. The best thing to do about ABGs is to do more and more of them and apply the same principle every time. Does the patient have acidosis or not? Is it metabolic or respiratory? Is it compensated? These are the 3 questions that you have to answer with every ABGs. And once you did that multiple times, you'll feel more comfortable with ABGs. And I hope you have questions, and please send them to Catherine.